In Java, the default constructor automatically initializes all instance variables to 0 or the equivalent of 0. In C++, the default constructor doesn't perform any initialization. Rather, it simply calls the object to be instantiated in memory and variable for use. Multiple inheritance. C++ supports multiple inheritance, but Java doesn't. This is a feature of C++ which allows multiple parent derives a class. Despite the strong features of multiple inheritance, but the use of complex and raises many problems. The compiler is not easy to achieve it. Here is one example which is showing the general form of multiple inheritance. Java allows the class inherits multiple inheritance. Java allows the class inherits multiple interface. This is to achieve a C++ multiple inheritance function, but also to avoid C++ implementations of multiple inheritance bring inconvenience. Java allows the class inherits multiple interfaces. This is to achieve a C++ multiple inheritance functions, but also to avoid C++ implementations of multiple inheritance bring inconvenience. A Java interface is almost identical to a C++ class that has nothing but poor virtual functions. In Java, you cannot inherit from more than one base class, even if the base classes have nothing but abstract method. However, you can implement more than one interface which amounts to the same thing. For example, in Java, you can create the interface for a stack as follows. This stack is roughly identical to the following C++ code. However, a Java interface is not a class. The functions declared within a Java interface cannot be implemented with the interface. Moreover, a Java interface cannot have any member variables. Because interfaces cannot have function, implementation or data members, multiple implementation of interfaces does not lead to the problems that caused virtual inheritance to be added to C++. That is, in Java, there is no need for virtual inheritance since it is impossible to inherit the same member variable from more than one path.
Pointers. In C++, a variable that can refer to an object is called a pointer. Pointers can be manipulated directly as memory address values. Pointer arithmetic is available in C++. Now, here, one example to see how pointers handle in C++. Java references are closer to C++ pointers than to C++ references. A difference between Java references and C++ pointers is that you can perform arithmetic operations on C++ pointers while you can't do arithmetic operations on Java references. In C++, one can construct pointers to pointers, while Java references only access objects. In C++, it is possible to declare a pointer to a const type, that is, you cannot modify the object pointed to by the pointer using that pointer. This is not possible in Java. The Java language does not support pointers. Instead, it provides similar functionality by making heavy use of references. Pointer is powerful but can lead to a lot of time spent hunting down complex and often subtle bugs that arise as a result of having unguarded memory access. Reference approach prevents command errors due to pointer mismanagement. It also makes programming easier in a lot of ways simply because the correct usage of pointers is easily misunderstood by inexperienced programmers. C++ does provide references too. It considers them as aliases to another variable or object. They are safer than pointers where they can be used. There is another significant difference between C++ and Java. Java has a garbage collector that automatically reclaims all objects that are no longer needed. In C++, it is the responsibility of the programmer to manage memory. A reference must be initialized when it is created. A pointer can be uninitialized. A pointer is an object containing the address in memory of another object, while reference is an alias for another object. References refer to some object and are bound to an object during creation and are used as aliases to that object. Because references are aliases, the contents of the reference is actually the contents of the object they are bound to. The contents of a pointer is the address of an object. The value of a pointer can be changed during its lifetime. References are bound to an object and it cannot be rebound during its lifetime. The contents of a pointer is the address of an object. Pointers are not bound to any object. Rather, they simply point to an object. The value of a pointer can be changed during its lifetime, causing it to point to different objects at different times. References are bound to an object and it cannot be rebound during its lifetime. Memory management. In C++, any memory that is allocated on the heap must be explicitly freed by the programmer. Forgetting to free memory leads to memory leaks, and in long-running programs can lead to the memory usage of the program growing very large. Java supports automatic memory management using garbage collection, but other system resources often have to be explicitly released if the garbage collector cannot determine they are no longer used. Garbage collection meaning that memory is freed automatically when it is no longer reachable by any references. This prevents memory leaks but can lead to pauses in execution while the garbage collector runs. Also, there is no promise of timely destruction in Java. Here can see one example for the garbage collection. The garbage collector is a huge implement over C++. It makes a lot of programming problems simply vanish. It might make Java unsuitable for solving a small subset of problems that cannot tolerate a garbage collector, but the advantage of a garbage collector seems to greatly outweigh this potential drawback. An exception handling. An exception is a representation of an error condition or a situation that is not expected result for a method. Exception handling is accomplished through the try-catch mechanism or by a throw clause in the method declaration.